Good evening. We have a really great show for you today. Dr. Wyrick and our friends are going to answer questions. What is the truth? Dr. Ergy is also in the studio. He's going to add his perspective. Dr. Orville Wyrick is a former member of the Artificial Intelligence Facility at the University of Georgia. And Dr. Andy LaFrenz is a retired lawyer, Doctor of Law. The question of what is truth is important to artificial intelligence and law, as well as medicine. Good evening, doctors.
Yes, good evening. And let's go right into our first subject, which is what is truth? Now, in philosophy, this question is answered by the branch of philosophy called epistemology. So we'll leave that fancy word aside now and move on. And we'll talk about scientific truth. How do we get scientific truth? Well, scientific truth is obtained by applying the scientific method. Now, if you look up scientific method in a textbook, any textbook on science, introductory science, you will find a definition of the scientific method, and they're all a little bit different. So please bear with me. I'll give you my summary. Basically, in scientific method, you start off by observing something in nature, and you say, I wonder, and you make a theory about why that is and how it works. And after you have a theory, you design some test or experiment to prove your theory right, or maybe prove that it's not right. And you do the test, you observe the results, and then you accept or you reject your theory or your hypothesis as to why whatever you saw actually occurred. Then, very importantly, you publish your conclusions, and other researchers repeat your experiment, and hopefully they confirm that they got the same results that you got. Now, if you do that many, many times with many different researchers all over the world, then we come to a scientific consensus that we call a law of physics. Now, there are some limitations of science. First of all, we cannot prove a negative. That is, we can't prove that unicorns don't exist somewhere in time and space. And even laws can require correction. But let's go back to this cannot prove a negative. Andy, in jurisprudence, in American jurisprudence, we have this concept of innocent until proven guilty. Is that the same thing as you can't prove a negative? You don't have to prove that you're innocent. It's up to the opposing side to prove that you're guilty. Is that generally true in science?
Well, in science, tell me, you're the scientist, but you start off with an hypothesis and you prove the truth of that hypothesis. In law, you have burdens of proof, if you will. That is, the prosecution in criminal law has to prove beyond a reasonable doubt. That's a standard of that he has to reach in order to convict someone. And there are various standards. In civil law, the burden is on the plaintiff to prove by the preponderance of evidence. The next standard above that is by clear and convincing evidence. Again, in civil law, typically that involves, for example, removal of a child from their parents on grounds that the parents are unfit. In that case, you have to prove that by clear and convincing evidence. The highest standard is in criminal law, where you have to prove beyond a reasonable doubt. Now, that's not beyond a shadow of a doubt, or there's no doubt at all. It's beyond a reasonable doubt.
Yes, so I think that what you're saying is, what I was trying to say is that by default in law, we assume that the person is innocent, and then it's the burden of proof of someone who is trying to say that you're guilty of some kind of wrongdoing or inadequacy. And if that burden of proof can't be met, then you're not innocent. But you don't have to prove you're innocent.
Right. It's a presumption. That is, if the prosecution does not come forward with evidence beyond a reasonable doubt, then the defendant doesn't have to do anything, and he will be discharged by the court without a conviction.
Okay, so I think that everybody can see how that relates to science, where you can't prove that something it doesn't exist. If you find one example of a unicorn, for example, anywhere in the universe, or proof that one existed in the past, then you can say, hey, unicorns have existed. But just because you haven't found it yet doesn't mean that you can't say there is no such thing as unicorns. So it's the same thing. You're not innocent, or you're not guilty. You are assumed innocent. It's assumed that there might be unicorns somewhere. We just haven't found them yet. We just haven't proved that the person is guilty yet.
Right.
Okay. So, continuing, even laws of nature or of physics can require correction. For example, just one example, the laws of conservation of mass and energy used to be taught in all the textbooks. And then this fellow by the name of Albert Einstein came along, and he proposed that energy is equal to mass times the speed of light squared, E equals mc squared. And that has been proven by scientists throughout the world, and the fundamental proof of concept is the atomic bomb, which actually takes matter, mass, destroys it, and creates energy out of the mass. So, and it works has been proven to work both ways. So we had to change the laws of nature to accommodate this new knowledge.
Just so I understand, the law of conservation of energy and mass meant that the mass in the universe never changed and the energy in the universe never changed, and Einstein came along and showed that they're interchangeable, and they do change.
Yes, they are interchangeable, but there's a relationship so that the total mass and the total energy has to stay in balance in the universe according to current understanding of physical law. Now, that may change tomorrow. There's a lot of interesting things going on in astronomy and so forth with expanding universe. And so I'm not going to bet that all of our current laws of thermodynamics and motion and so forth are going to be preserved in the long term. I think that we still have more to learn. And that's science. We're always open to learn more. So let's talk about what's outside of science now. There are real undiscovered truths that are out there, and we can't say they're scientific. They're non-scientific. It doesn't mean that they're unscientific. They're just non-scientific. They don't have a status yet. And for example, there was a time when nobody knew about the planet Pluto, and it didn't exist to science. And then some astronomers noticed that Newton's laws of motion were not being obeyed precisely by the other planets. And they said, well, what could cause this? And they did some calculations, and they said, hey, if there's another planet that we don't know about, and it's located there in space, and it's moving in this direction, that could explain for what we're seeing as a deviation from what we expect from the laws of nature. And sure enough, they looked and they found Pluto. They're still arguing about whether it's a planet or something else, but nobody denies that it's there and what its mass is and how it's moving. So that's an example of how science is advancing. And then there are many traditional healing theories. Acupuncture proposes qi and channels, and we don't quite understand those in science. Ayurvedic medicine proposes chakras. Homeopathy has some basis in experimental methods like the scientific method, but it also has some conflict with what we understand as the physical laws of nature. Applied kinesiology, that is not something that is proven by science, but I'm not going to say that science has disproven it either. And I will go so far as to say that science cannot disprove these things because you can't, using the scientific method, prove a negative. You can only say, well, we haven't had confirmation of that particular theory yet. And same thing goes for deities. The God of the Bible, for example. Can science prove that he exists? No. Can science prove that he doesn't exist? No. And therefore, we say that true science is agnostic. It's not atheistic. Agnostic means, well, we haven't seen the proof yet, but we're open to the proof. So that's the main things I wanted to say, and we've already talked a little bit about the standards of evidence. In law, we have the civil law, the preponderance of evidence. We have beyond reasonable doubt in criminal law. In allopathic medicine, the standard of proof for most purposes is 95% probability. So if a patient, we cannot say that a patient is 95% certain that he's or she is abnormal in some way. We say the patient is normal. And there's another type of medicine that I practice is called functional medicine, where we look at the shades of gray. We don't say that if there's a 94% chance that the patient is abnormal, they're perfectly fine. And then if they cross that line, add one more point, suddenly they have a disease that we can diagnose and treat. So in my world, it's a continuum from probably normal, probably fine, to probably sick, to really certain that they're sick, but there should be interventions in between. Dr. Ergy, do you have any comments on this?
Dr. Weyrich, you're so smart. I'm so blessed, and just a wonderful experience at Pace and Health and Wellness, and it's just a great feeling to be around incredibly brilliant guys like you. I'm just a poor country psychiatrist here trying to make a living, Dr. Weyrich. A lot of what you told me, I was able to follow a little bit. I thought that was pretty impressive. I wanted to ask a couple of questions. So Isaac Newton was one of the most influential scientists, I don't know, 1600s or 1700s? I'm not quite sure.
Yeah, I'm not sure about the exact date either, but he developed the three laws of motion, which are something like an object at rest tends to stay at rest unless acted on by an outside force. And I won't bore the audience with all of his laws of motion, but laws of motion of Isaac Newton are very important. Laws of thermodynamics are very important.
So that's just, incredibly fascinating. You mentioned that true science is agnostic in itself, and I believe Isaac Newton actually was a person of great faith, and I just think that's just a fascinating thing. And there have been many scientists out there who have described themselves as atheist or agnostic, but there's many incredible scientists out there who have very deep faith too.
Yes, and not just scientists, but also lawyers. There are a number of books out there written by lawyers. One of the first was entitled Evidence That Demands a Verdict, where a lawyer who happened to be an atheist decided to prove that the Bible was bunk. And by the time he was finished, he had convinced himself that by applying legal standards of evidence, that it was all true.
So let me ask a question. As a psychiatrist, do you think the field of psychiatry or psychology is a science?
It falls in the category of what are called soft sciences, which means that I would say part of it is subject to experiment, the scientific method, and some of it is out there in the same place as the unicorns and Pluto was. We don't fully know, but we can apply legal standards of evidence. A lot of things meet the preponderance of evidence test, but wouldn't rise to the point of being a law.
That's cool. So when I was a kid, Pluto was a planet, and then it was determined that it wasn't a planet pretty recently, and it just totally shook me. I'm a space guy. I love that stuff. And I was like, we had 9 planets, and now we have 8 planets. I was like, well, at one point in time, it was 9. That's a pretty concrete number. And then it changed to 8. It's like, I mean, how does time fit into that? Because at some point in time, if people really believe something to be a universal truth, at one point in time, it's a universal truth at that time. And what's to say what we're saying is any more correct than it was back then?
Well, to quote a well-known politician, it all depends on what the definition of the word is. But the problem with Pluto is that not that it doesn't exist and have a known mass and a known trajectory. The problem with Pluto is its trajectory is a little bit different from the other planets, and so maybe it should be called something different than a planet, but it does exist. And I think we have a caller.
Oh, hello, everyone. This is Chris, and I just wanted to comment on psychology and psychiatry being a science. There was a big push, especially in the 50s and 60s, by Skinner to make psychology a science, and he was very focused on only dealing with what was measurable and using standard scientific methods. And many psychologists argued against what he was doing because they said he left out a lot of things, a lot of possible theories and thoughts and philosophies, but he was focused on making a science essentially following the model of physics and only dealing with what was measurable, only using the scientific method, and if you could measure it and then test it, then it was possibly considered valid once the research was done. Anyway, I wanted to make that a point. That was a major schism, you might say, in psychology, in terms of how to conduct research, in terms of what to view as truth. So anyway, that's my comment to the show so far.
That's awesome,
anyway,
Chris.
It's a great show, fascinating.
Appreciate that. Thank Dr. Weyrich for that. I mean, it seems like when we are going through time, the field of psychology is one that I could express some opinion on. The mind is so mysterious, and it seems like the more we know about the mind, the less we really know about it. And there are some things in life that we know a great amount of, and we can measure it in great detail. But measuring, I mean, how do you measure happiness? How do you measure feelings?
You bring up a good point, and that was what Skinner was looking at, and that's why he focused on only behavior. He didn't even use the concept of mind, because do we have a universal measurable definition, operational definition where we can define it in measurable terms? And that's not agreed to. There isn't such a standing, doesn't exist. So therefore, he focused on what could be observed and measured, which was behavior. And of course, the whole field of behaviorism grew from his thinking. But so what you point out is the exact dilemma. We want to talk about other factors. We know other things exist, or at least we suspect they exist, or other concepts and ways of thinking. But where's the proof in the bun? Where's the measurement of it? How do we know how to test and how to experiment and how to arrive at some proof? Anyway.
Exactly.
Thank you, Dr. Urgi. There's a lot more that we can say about what is truth, what is not, and how we can discern the difference. Stay tuned for future editions on KMOG and YouTube on this critical subject. If you like this video, don't forget to share with your friends and visit the website weyrich.com/drweyrich/multimedia-archive.html, where Weyrich is spelled W-E-Y-R-I-C-H. There you will find additional information about this and many other topics. Now, I want to turn it over to you. What was the most important thing you learned from this video? What more do you want to know? Let me know by leaving a comment below.